Okay, so another day of development, videos, etc., etc. Now, I may sound a little bit sluggish as I just got back from eating out and ate at an all-you-can-eat buffet, and needless to say, I stuffed myself on vegetables and potatoes and stuff. Um, Ironically, I took some pictures, by the way, when I was there. My brother basically just filled his plate with chicken and then ate nothing but chicken. You look at my plate, and I've almost got nothing but vegetables on mine. I'm not vegan, by the way. I actually did get some meat, but the other vegetables are good. Anyways, last video we worked on the extended block system. This video we're going to continue on that. I know it's boring stuff, but we do a little bit of this back end stuff, and eventually we'll get back into working with things. Here, maybe tomorrow or the next day, we're going to work on ICBM Classic a bit and get it polished up, as I've got a bit of ticket reports from Lim here, who's been testing ICBM Classic against his mods, and has found that there's quite a huge balancing problem. I'm not too sure we're going to really change a lot about the Classic version of ICBM, because the really thing is it's meant to be unbalanced. It's actually not meant to be a very balanced mod. That's the reason why when we rewrote ICBM, we actually spent a lot more time balancing it, and the explosions are weaker because of that. So for the extended block manager and stuff, we haven't put anything in here. I did actually initialize a few methods here, but we haven't tested if anything works. We haven't gone through and ensured that we're getting the correct values. So before we go any further, we're going to test this class here, and then we're going to test a few other classes. Yeah, let's test the chunk, then test the section. Get this a little bit documented out while we're testing it, and then we'll move up. So we'll start with the section, then we'll move to the chunk, then we'll move to the map, and then when we get done with the map, we'll go with the manager. And that way, by the time we're done, we've got most of the bulk tested, and we know there's problems. Now, one thing I like to note is, even though I was talking about using a byte for this, we are using a short for the extended block storage, so that means it's going to use up about 41 additional megabytes per player. That's if the players are not next to each other. Of course, if the players are nearby each other, their chunk boundaries are going to overlap with each other, so it's going to be less. Now, this is maximum amount of storage. This is not actually what it's going to use. The likelihood is it's going to add 5 megabytes per player, because most of the time, half the chunks are empty. And then we're only going to be using the extended storage if there is blocks from my mod in those chunks. So if we hit, say, heated stone is used, heated stone will use the extended block storage, and then that could be maybe only one layer, so that may be a couple kilobytes added to the memory storage. So it's not going to be too big of a deal. So for those of you who are running servers and already having problems with memory, don't worry about it. And if it's a really massive problem, what I will do is create ways to turn the extended block storage off, and I'll try to give as much possibility to control memory management for those who absolutely don't need these features, or don't want them, or are running on a potato for a computer. After all, I want to make sure that these mods are accessible to the most people possible. Anyway, so for testing, we have our own little test package. It's not test, even though you would imagine that would be test. This is, I don't know what this is. I believe this is something I was using for classwork at one point in time. Actually, you want to know what this is? I was doing a job, and I needed to write code for a job in order to apply for it. This is that code. This is where they wanted to do coupons and all kinds of stuff, and they would give you like code to work with, and they're like, hey, I need you to sort this, I need to do that, I need you to validate credit card information. This isn't all of the code that they wanted me to do, but that's pretty much what that is. So that answers why I've had that in there for I don't know how long. But that's right. We put this. We changed where the test package shows up at. So we're going to go com build broken tests. Then we're working inside the lib world, and we want to make a package called maps, or map. And then we want to put a placeholder in there, which I think is what this is. Yeah, it's a placeholder. Let's go drag this up here and we'll recycle it. There we go. So that way I can recycle my placeholder and not have to reuse it. So we want data is what we're testing right now. And we want to test chunk section, I believe is what it's called. Yeah, chunk section short. Now, interestingly is this doesn't have any Minecraft code in here yet, so we could actually test this without the Minecraft code system. So all we have to do is extend, I want to say test case is what it's called. Yep, that's what we want to extend. And then what we need to test is we need to test creating it. So initialize, and then set and get values, and we need to make sure that this is returning the correct value every single time. I don't actually know how bit shifting works. This is something that's still a bit of a weakness on stuff here. So let me Google this. Oh, I hit clips instead of that. Okay, so bit shifting Java. Whenever in doubt, just Google something. So bitwise bit shift operators. So this is what we're using right now, is these little operators here. So shift to the right, shift to the left. So we're shifting this to the left, and we're saying how many times I think we want to shift. What I'm trying to think, oh yeah, here's an OR operator. So bitwise operator performs a bitwise inclusion OR operator. So that's an OR operator. I mean, the thing is, I believe I got this from Minecraft code, so it should work. But I'm not quite sure what we're supposed to get result-wise from it. I mean, we could probably just test it real quick and just go with whatever. So let's see if we can find a better thing here. Okay, so 1 shifted by 1 results in 2. That makes sense. Shifted by 3 equals 8. So you're shifting it over 3 times. Okay, so this will be a little easy if we just remember left and right, and then I can pretty much do most of that in my head. It's this OR operator that I'm trying to figure out what it actually does. So that's where I'm confused at the moment because I'm not familiar with all of them. So it's a bitwise inclusive. Oh. That was going to mess with my head, but I actually understand what it's doing now. So if you look at these, it's pretty much putting them together. What does it do when you have an overlap, though? So we have an overlap here, but okay. So what it's doing is it's going, okay, if either or of them are high. Okay, I'm going to pull out Paint for this because I actually do. I've studied electronics and stuff, and I actually do know what it's talking about. Okay, so say for example we had a better way of doing this. Actually, I could just do this real quick. Control C, Control V. This is where I wish I had demos on hand for all this kind of stuff. I'm just going to start making demos here eventually because of the fact that I know at some point in my life I'm going to end up as a university professor because of how much I actually do enjoy teaching people. But, okay, so say red is high, so we say we got this, for example. And we're going to use green as 0 because whatever. So what this would work as is we would end up with a 1 here, a 1 here, and both of these are high, so we're going to end up with a 1. And then down here, we're going to end up with 1. So we end up with 1 in all these. So if either or of these has a 1 as a signal, because high is a 1 here, and this would be a 0, not that that's going to show up. So that's a 1, that's a 0. So if either one of these is a 1, we go with 1. Either one's a 1, we go with 1. That's what it's doing right there. That's what's confusing me. That's where I'm not quite sure what's going on. So we end up with a bit shifting here. We're bit shifting by 8, bit shifting by 4, and then we're not shifting Z at all. This number is going to be between 0 and 15. This is going to be between 0 and 15, and this one is going to be between 0 and 255. No, actually, this is going to be between 0 and 15 as well. Let me make notations of that. 0 to 50, because we actually use an AND operator on here. So I actually have known what the AND operator does. It actually will pretty much guarantee something stays within a certain range. They show it down here. This document's not exactly the best place to. I'm gonna bookmark this document because it's useful. So we'll go ahead and close that. What university is this from? Rice University. I think their classes are very similar to Franklin's because I recognize some of this material and I recognize the class number. So this will get the position in the data array for the 3-dimensional location. So what this does is this takes the 3-dimensional and turns it into a 1-dimensional position data. We use a 1-dimensional array because it saves on memory. Sort of saves on memory. Might I note when you open this up, you are guaranteedly reserving that many amount of positions for shorts, which is going to be, if we pull this up, 4096 times 2. So you're going to be using 8 kilobytes of RAM just for that to exist. That's not anything actually used in there. Everything initializes as 0. So if you just want to store one value, you got to use 8 kilobytes of RAM. So that's 8 kilobytes of RAM for 2 bytes worth of information that you may actually be using. It's one of the big things with reason why computer science is a thing. People always go, oh, computer science are just glorified programmers. We're actually not. We're experts in mathematics and data management. So we do most of the field of computer science has to do with math, understanding how math works in a computer, understanding how data works in a computer, understanding how to build algorithms to access that data, manipulate the data, and end up with a result. And it goes like so in depth of that, but you're half mathematician, half engineer at some level. There's better explanations than that because my explanation is horrible. But yeah, we know that. So this will return a value between 0 to 495. So even though it goes to 496, you got to remember position 1 is actually 0. So you're actually 1 less than that for your final value. And this will be inclusive. Lem's sitting there sending me some videos that I may talk about here later of how his mod works. So I'm going to try to work on compatibility with his mods here because he's talking about balancing problems, and the best way to fix balancing problems is add direct compatibility. So get this. This will be the first thing we test, which means we're actually going to want to, you know what, we're going to do this real quick. Public static. Because this is recyclable. And now we're going to do public. Unfortunately, one of the downsides of using JUnit testing is that, hold on, let me talk to Lem here. Okay, so test this real quick. So go over here. This is, by the way, if you want to pay attention how to use JUnit testing, it's this simple. Public void test point, and then you just do that. And if you want to be double thing, you can go AK test. You can put an annotation up here. When it comes to using it, JUnit 3 requires the name be test. JUnit 4 requires it to be the annotation. It will still backport to the older tests, so you don't have to fix everything. So you can pick either one of these. I use both for consistency because that's just how I do everything. I would honestly just do it this way as well, because then you know this is a test method instead of it being that way, so you don't have to check the annotations every single time. How we're going to test this is... I don't know an easy way to do that, because I legitimately just don't know how this adds up. I'd assume if we put 0, 0, 0 in, we should get 0. So let's try that. So we're going to want to make a new chunk section. So chunk section short. and then we're just going to call this chunk actually just to be simple. And then we're just going to go chunk.get, or yeah, it'd be point, and we pass in 0, 0, 0. I'm probably wrong on this being 0 because I don't know how this math actually works out in my head yet. I haven't done a lot of planning. I mean, every single one of these dev videos I do, not a single one of them is planned, just so you guys know that. I want to get to a point where at some point they may be partially planned. Like I would go, okay, we're guaranteed they're going to be working on this mod this day and we're going to be working on this piece of content. That kind of sort of worked out because I mean, I know we said we're going to be working on this, but you guys have noticed I've just changed my plans randomly. Okay, so that does end up to be 0. I'm trying to think of a way to mathematically ensure that I have the correct data point for every single point in here. Because we could go between 0 and 4095, and we could do some weird stuff to make it work, I guess. I just can't think of on the top of my head how that actually works out. This is the reason why like they spend a while in college teaching you how to do this stuff. Is I did not pay attention to my bit shifting class. I think I actually just completely skipped that week because I was like, I don't need to learn this stuff. I'm never going to be messing with bit operators. And here lo and behold, we're messing with bit operators. Always comes to bite you in the math. If you're just now like watching these videos and you're listening to my advice and stuff, and you have yet to go into college or yet to take a programming class or mathematics class that's really heavy, pay attention to everything. You don't know when it is going to help you. Like because I never paid attention in school to my mathematics, I actually barely passed calculus. I took 3 semesters of calculus. I took 3 semesters of calculus-based physics. I barely passed them all. Even though I started doing things like black hole physics and stuff, I failed most of my exams because I never paid attention to class. And this is the same example. Yeah. So what I think how this is going to work is if I put a 1 in here, it's going to turn into 255. Is what I think is going to happen. Because if we put a 1, and then we shift it 7 positions, so 1, 2, 3, 4, 5, 6, 7. It's actually been shifted to 8 technically. Then our deck value is, no, that's too high. Oh, I see what I messed up on. Okay. Clear. So we get a 1. Then we've shifted it there. 1, 2, 3, 4. There we go. That means our deck position is 128 right now. And then if we pass another 1 in here, we would end up with a 1 right there. And then we pass in our Z. So how this is working is your Z position is going to be these last few numbers. So Z max is out at 15, so that'd be 1, 2, 4, 8, which adds up to 15 if I'm not mistaken. Can I open up 2 calculators? I can. Standard mode. Okay, so if you go 1 plus 2, my finger didn't slip there. 2, that's 3, then 4, plus 8, so you get 15. So 4-bit position is 15. So that means your last few coordinates are your Z coordinates. And that means my next 4 are my Y, and then my next 4 are the 8. So this actually needs to be shifted. I want to say 1 more. Yeah, that actually makes perfect sense now. So that means, yeah, as I said, it was going to be 255 is what I guessed, but it's actually 256 is what it's closer to. Because it's been shifted 8 positions. And what it goes is it goes, shoot, I need a notepad here. Got my notepad over here. So when you do bit, by the way, how bit positions work is you're counting in doubles. So you go 1, then you go 2, then you go 4, then you go 8, and you use combinations between these. So if you want the number 3, you make the first 2 on, and then that gives you a number 3. If you want the number 5, then it'll be this position and this position. If you want the number 6, then it'll be these 2. If you want the number 12, then it'll be these 2, and so on. But it goes like this all the way up. And this has been like hammered in my head for years because I studied electronics for 2 years in high school. Then I did engineering. Engineering, they hammer this in your head. And then, of course, I became a programmer, so that got even further in my head. These last 2, I'm not quite sure they're exactly correct. So that'd be... So that's definitely going to be 500 there. Then... No, this is wrong. This is 6. I got that one wrong. Didn't take long for me to mess something up. Then if we do this, this is going to be 24, which means this one is going to be 48. There we go. So these are our positions, and this is how we end up. If you turned all of these on to one value, this is how you end up with 4,096. They're pretty close. Where's my calculator? We can add them all up just to confirm that. One thing when you're doing this kind of stuff, you always want to make sure this is correct, because if you make a mistake anywhere here, it can turn into a complete disaster in the game. There's so many mods I've watched that have, I'm going to redo this here. 1 plus 2 plus 4 plus 8 plus 16 plus 32 plus 64 plus 128 plus 256 plus 512 plus 1024 plus 2048. Yep, 496. So that works out well. That's really cool to watch how that works. And I'm going to hit don't save on here, and we're going to write some notes here. So x takes the first 4 bits, y is the middle 4 bits, and then z is the last 4 bits. And then just to double this up, what we'll go is we'll go x, 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 y, 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 and then z, z, z. So anytime I come down here, I can read my notes and I immediately know what's going on. This is where I talk about when you want to document everything about your code. If you ever have a moment where you are confused, like I was just here with how that worked, document the living snot out of it, research it, and then try to master it. And even if you master it, write notes down, because at some point in time you're going to forget how you mastered that. And you're going to go like, I think this is 255, but I'm not sure. And if you ever get confused like that and you don't have notes to rely on, then you got to repeat the process of researching and mastering it again. But notes allow you to master things really quickly. And that works out. Is then we know exactly how this ends up to be. This means we are actually only using 12 bits, or 1 1/2 bytes. So we're not even using a full short value when it comes to this, although this is going to use an integer. Arrays actually do use integers for memory storage. We don't actually need a thing here, so this is going to be a short. We're not going to cast that. We're just going to store it in it. Okay, let me go talk to Lim here in a second again. Okay. So that's good there. So we know how that works. So we know how exactly our data is going to sit there and work at. Where did I put my test cases here? Okay, so I don't want to go through and do all 4,000 of these by hand. So we need some ingenious way to test this. But the problem is that the only way to actually, I know so far, to test this quickly would just be to use the exact method we're using. Okay. So we could test z real quick. So z would always be between 0 and 15. Y is going to be all over the place, and so is x. So like our first one's going to be 255 for this one. Then our second one is going to be 512. Then 3 is going to be a combination of those two, so it's going to be like 700 and something. We could test 0 between 16 for each one of these, but then that would still end up with us doing 16 times 3 number of tests to do. And then we're not doing combination tests. That's why I always hate doing this kind of stuff, is that there's no easy way to do it. And I don't want to do it the hard way because you end up with 4,000 combinations. Okay. So let's think through our heads here. Okay, I'm just going to drag that over there and stop listening to it for a few seconds. Let's go ahead and get Z out of the way real quick, and while we're doing that, we'll move on because I'm pretty sure this methodology is going to work. As long as I don't change that equation, it's going to be exactly the same. So let's start with Z, so we're going to test Z. I have an idea in my head how we can do it. It's going to involve just really flat multiplication. So this is going to be I, and then what we want to expect in return is going to be I. And then we'll just run that. So run test point. Man, my phone's like every one of my chat systems likes to blow up at the same exact time. So yeah, we got exactly what we expected there. Now what I'm thinking to do to test Y is we always know it's going to be times a certain value. So let's try timesing by 16 and see if that we get exactly what I think we're going to get out of this. That worked. Okay, so we're going to times this by 256 and then times this by 256 and see if that gives us, you know, that shouldn't have worked. This should have crashed, actually. You know, this is not going to work because we got a fluke because we accidentally mistyped. And it ran off the backup code, I think. Oh, with this, I missed a bracket. Yeah, a little error thing popping up on the other window here. One of these times I'm actually going to work on getting it so you guys can see the other monitors when I'm working. Yeah, that's what we thought. So where this failed, okay. So we were expecting 16, but actually got back 256. And also this is wrong spot. Actually, you know what? You know, I'm failing to do here. This is flat out just still I. That needs to be 16. Okay. We're getting some weird math here. Hey, it did work. Okay, so we do have something going here. That test Y and this test X. So it works. The next test would be to run through all 4,000 something positions. So let's do it the easy way, where we're just gonna do a bracket per thing here. So this would be X, then this would be Y, and then your last one would be C. So what we're expecting to see is 256 times that plus y times 16 plus z. That's what we're expecting to see. And we'll go ahead and run this. Yeah, works. So we know we're going to get the exact results back. So that test our point method, that's probably the strongest spot of our code that if it failed, it would take out the whole system by itself. So it's good we can actually see for a fact that when this runs, nothing fails in here. Of course, we got no debug to look at, so we can't see like what the values are or anything, but that's not really necessary. So the next thing we want to test is we want to test the get value. I'm going to make this public real quick. Man, he's going to just throw code at me for the next couple minutes. Yeah, I'll work on that later. Probably next few videos we're going to be working on ICBM Classic, as I noted, to polish it, and we're probably going to be working on ICBM again because I want to get back into that. We do have to still finish the nuclear blasts. I don't know what we're going to do with our schedule here exactly, but we're going to get things figured out. As I've noted, I kind of want to start planning these out a little bit more. What I'll do is I'll start announcing like a week ahead of time what we're going to be doing for each video. That way you guys know if you want to tune in or not, and we might start streaming these videos again. I've been told by a couple streamers the reason I'm not getting a lot of people on the stream is I'm not announcing early what's going on. Okay, so we need to do the set values here. We need to do the get values. So get values come first because get values are the most likely to fail. And then, yeah. So public void test get value. And then we want to also do test get value pause. The reason we're making a slight separation for these is just to ensure that the pause object itself is working and not the get value. So how this will work is we'll create a new chunk set. Then we're going to go chunk.data, and we're going to say 10. So 10z is what we're going to set to 15. And then surprisingly how easy this is you just call chunk.getValue. We're going to go 0, 0, 10. And then we want to put an insert statement. So we assert equal. By the way, assert equal is what you're doing is you're asking is the first value, which is what you're checking against. So we're checking 15 equals the second value, which is what you're actually comparing against. There is assert same too. Assert same is not the same as assert equal. Assert same wants to know if it's exactly the same object. So if you had two objects and they both equal 15, they're not going to be the same. One is going to be data object created at this point in time, and the next one's going to be data object created a second later. So this will work. And then let's go ahead and test an x value, and we'll call it on that because there's no point in testing further. So we're going to go, okay, if 256 equals 10, or 15 actually. Oh, wait. No, this needs to be, actually, you know what, we'll do this. Actually, we'll make this like even some weirder number. That way there's no chance of duplication. And then this one's going to be 1, and this is going to be 0. And then what we do to do this again, we're just going to copy this exact same setup here, move it down here. Between test runs, as long as you're using test cases, these are going to clear out memory-wise, so you don't have to worry about... actually, you didn't have to worry about duplication because you're creating brand new objects between each one of these, so you didn't have to worry about that at all. But say you had some kind of global objects. We do use world objects a lot to test actual in-world values, which we will get to here eventually. Probably not this video, maybe the next video we'll maybe get to that, but yeah. For this, we want to do new pause 0, 0, 10. Actually, to make this more interesting, 13. Because we want to make sure that the actual X transition is working perfectly fine. And then we'll just do a normal thing down here. So we'll just go new pause 1.0.0. And then what we're going to do is we're going to run all these. And they run perfectly fine. The next thing to do is to check to make sure the set value works. So this is going to be pretty much the same thing we just did, except instead of calling get, we're going to be calling set. So this will be set value. And what we're going to do is we're going to have a prefix value that's going to exist there. And then what we want to make sure is that when we call set value, we get 15 back, and that the new value is 20. Value, oh wow. I forgot that we don't auto promote down for some reason. Oh wait, yeah, this doesn't do the check. So we just want to go here, do this. Then we want to make sure that this is actually now equivalent to 20. Is this really not auto cast down? Huh. I'm going to make a new method for this because of the fact that I don't like how that works. It's one of the things I've actually slowly stopped liking about Java is that there's no auto demotion. For those who don't know what I'm talking about, some languages have this really cool feature built into them where you can take different data types and auto convert them without asking the programming language to convert them for you. So say I'm using an integer. Integer is bigger than a short. Integer is like 2 billion, a short is 32,000. It can auto convert it down and auto convert it up. Java only does auto promotion, which means it will only increase the data size as needed. Languages like C++ can do both directions automatically for you. There's other languages that don't allow it at all, though. But I don't like the way that that's handled because that's a little annoying in my opinion. Because most of the data values we're going to get are going to be integer based, and we want to try to auto convert them as best as possible. So yeah, we'll go ahead and implement that. And then we'll go ahead and test it. So that's 20. And then our next test, of course, we're going to go ahead and just implement the same exact way. So we'll go ahead set value. And we want to make sure that a new value we're putting, which will be like 457, for example. Or let's make sure it's a little bit different than our value so that way it's not that close. And then we want to make sure we're not calling the get method. I'm basically doing a 100% test thing where I'm separating my methods out. A lot of people would just merge the set and get together, and it's perfectly acceptable to do it that way. I don't do it that way because I prefer to have as much of guarantee of testing environment as possible. So here we go, we do our set stuff. We got a failure here. Oh yeah, I see what I messed up here. This is a 1. That needs to be 0. I couldn't imagine that code was actually flawed because it runs back through our code which we just tested up here, so there's no reason why these methods down here should ever fail unless we start adding complications to the code. Because if we go back and we look at this, this is like Java 101 code here. Anybody coming out of a Java class could write this code. So there's no reason why it should ever fail. Of course, I'm basically calling myself a nub when I say that the code I just wrote is meaningless. But it is true, this is not very complicated stuff. What makes it complicated is how we're using it. So we're using data structures and stuff in Minecraft where not a lot of people actually spend a huge amount of time with data structures. Most people make really cool content, they make cool magic things, that do cool animations. I'm spending a lot more time focusing on data structures because if you can make elegant, really good data structures, you take that ability to make really beautiful things and then you add massive amounts of capability to those beautiful things. You can do so much more if you actually spend time making your backbone for your game or game engine or whatever. Technically, we are building a game engine on top of Minecraft. It's a little ironic. So we've tested that. Fully tested out. Really basic. This is what JUnit testing really is. You're just going through and you're testing data. Now, realistically, if I was bringing this to a professional grade level, I would have more than likely put about 40 test cases here. We fully tested this. This is a 100% test though, so there's nothing to really do here. The only thing you want to do probably here is start testing bad data to see if your system is resilient. Resilience basically means is I can fuck with your shit and it would still function properly. Actually, you know what? Let's go ahead and run this with code coverage. And we should be able to then go over to our chunk section. And we should be able to look at our code coverage. I say that, and then as soon as I actually did that, it didn't work. I hate code coverage sometimes. It doesn't want to work sometimes. So how you have to actually do code coverage here is I'm going to have to pop over, test all the things, hit stop on it real quick, hit run, and then hit run test with coverage. Coverage is basically telling you what percentage of this method calls that you've hit with JUnit testing. The goal is 100%, but hitting somewhere around 30 to 50% is acceptable. That's where you know your program is running adequately. 70% to 80% is where you know your program is running really, really well. 100% is no, you've tested everything that you can feasibly test. But just to note, if you do hit 100% does not mean your program is safe from failure. Your program can still guaranteedly fail because you forgot to test something really simple. And what happened here? Ignore that because that's I'm gonna just pull that test here eventually. So I did some JUnit testing to guarantee that the AI improvement mod actually works. This is one of the sad things about it is it's really hard to prove that that mod is actually doing what it's doing, because if you run tests on it, it's 50% of the time it'll show that it's improving, 50% of the time it'll show it's running a little slower. And it has to do with how Java optimizes, and Java doesn't always optimize the same way every single time it runs. It tries to pick out the most used methods and it tries to optimize the most used methods. And sometimes when you're running a JUnit test, your method isn't being used enough. And I've got to learn how to make that work better, because I've got to get the Java optimization to run. Because what AI improvements does is it actually changes code around so that it optimizes Minecraft. It runs like Fastcraft pretty much. Only difference, I don't think Fastcraft targets the same code I do, so the two mods run together just fine. I fixed the problem without using ASM. I think Fastcraft uses a lot of ASM. Is this finished running yet? We're going to let that run real quick while we work on the next set of code. So here's where the problem actually starts to come in, where we actually do need a test. So we were testing this short section. That's just a warm-up. That's just to show that we can JUnit test, we can toy around and stuff. But the stuff that actually needs to be JUnit tested is these type of methods. Because when I was writing these, I wasn't so certain when I was writing these that this would end up with the correct result every single time. So that's what we need to test next. So actually, you know what? I think our test ran through. Yeah, here we go. See these green lines over here? These tell me how much we've run. Okay, it goes, okay, there's one test hit there, and we've run the one test hit. Actually, this was here earlier. I don't know what I'm smoking here. Anyways, test the next piece. This will be chunk, test chunk, data, short. And we'll extend test case for this one too, because we're not depending on Minecraft code. Yeah, we still haven't touched Minecraft code. As soon as we touch Minecraft code, we have to switch over to my test system, because as soon as you try to load something like a world or a block, it will crash the test system. It is incapable of testing the low-level stuff. Or not the low stuff, it's incapable of testing anything that tries to load the class loader from Minecraft. But all this stuff is, surprisingly, I could go take this to my own game, and I could use this right now. This is not dependent on Minecraft code whatsoever. This is, by the way, why we have our own license up here. For those who are like, oh, Minecraft mods belong to Mojang, they actually don't. There's only like about, usually somewhere between 10 to 20% of the code that's ever in a mod that is even close to touching Minecraft code. Most of it runs through Forge, and then Forge runs, of course, Minecraft, and that's how you kind of get that thing where people go, oh yeah, it's the same thing. It's not. Anyways, public void. So we just want to do set value. Okay, so test set value. And you want to test get value. So at test. And then we really should be running an initialization test, but right now there's no constructor in here, so I guess there is a constructor. Yeah, I guess we need to test the init method. So what the test init method is used for is it just kind of gets you that 100% coverage. It doesn't do much of anything. It's what you use to go, hey, we need to test this extra piece of code to make sure it's running properly. So we go chunk data short. And what else we got here? Because yeah, we probably have more methods here. So chunk data short, chunk, and then we want to say this is, say, like 10, 13. And then we want to go, okay, assert equals 10, and then you go chunk dot position dot chunk position x, and you just want to make sure that these are the correct values. That'll work. So that's our initialization test. And of course, we're just going to go down here and we're going to do the same thing here, copy that, and then we'll have test give method. Okay. So we're going to go chunk dot set value, and we want to test to, like, say 10, 10, or 10, 11, and maybe 20. And then we want to set the value of 100. Yeah, let me go ahead and fix this. I'm going to change these to shorts, or integer values. Okay, that automatically will do a conversion for me. And this will convert up, then convert down. So I don't have to worry about that too much. Actually, you know what? We're going to do this because somebody's going to probably bitch at me like, oh, why are you letting me use the lowest type? Why do I have to convert up to an integer and then back down to a short? Somebody will indeed bitch at me for that. I've developed I've developed APIs for such a long time that I know almost instinctively that somebody will find a reason to bitch about something. When I was making UE 3, 4, and 5, we had constant people going, hey, you shouldn't do this, you shouldn't do that, you should do it this way, you should do it that way, because everybody has their own way of doing things. It's the reason we never got enough supporters for UE, and the reason it collapsed is because everybody wanted to do their own thing. Too many chefs making the stew, basically. Which is sad because UE 5 was so well made that it would have put Thermal Expansion's power network in the dust if it wasn't for the fact that nobody wanted to use the API. That was the failure it had, is we could not get support for it. It ran really, really well. It ran twice as fast as the Thermal Expansion API, offered 10 times the capability, so you could do voltage with, you could do ampage. That's what you can't do that with RF. RF is purely an energy-based system. I didn't care what data types you used. You could reuse the network code for pipes. You can use the network code for redstone. It worked for a little bit of everything. It did distribution of networks a lot better than what RF does. RF is actually okay. I know I'm dogging on RF a lot here, but their stuff is actually pretty good. I have to admit that. Anyways, our previous value, so we're going to run this code. We're going to go assert equals, and the previous value, which is going to be returned by this, should be 0, and it should create a new thing. Then what we should have happen is that we're going to do a couple other things. Assert not null, chunk dot. Yeah, let me expose a little bit more. This is the problem with JUnit testing, actually, is that you end up exposing a lot of data. You can use reflection. I actually have done that. I actually got in trouble with my university because I was using too much reflection on their testing servers, and they were like, you're not supposed to do that. They were surprised somebody who's taking early classes is even knew about JUnit testing. So we want to do assert equal down here as well. So we want to make sure that the first section is not null. We then want to ensure that that's going to actually be a little tricky to test, actually. So data, and then what is our value going to be here? It's going to be 10 times 256 plus 20. And this needs to be equal to 100. That's pretty much. I was going to test to see if the section was identifying itself as section 1, but I realized I'm not storing that at all anyways. At least I don't think I am. Let's take a look at this. How we construct it. Yeah, we're not telling the sections what level they're on, but that's okay because they really don't need to know. So that's fine. So let's go ahead and run this. That should validate, yep. So we know that code works out pretty well. We're going to do the same thing here. Actually, let's run a second test here. I'm just going to duplicate the code up, so we're not going to have to do too much work. But what I want to do is I want to ensure that that previous value was 100, and then I want to put a new value here like 2. Well, yeah, we'll do that. That way I can ensure that the previous return is working as intended. Okay, that's cool. By the way, apologies on this video for there not being any exciting explosions, because I know somebody's going to comment eventually. Be like, hey, I saw your recent video, and they'll send this to me in private message on Discord too, because I don't understand why people can't just comment on the YouTube videos. But they'll be like, hey, you didn't do anything cool in your video, or why aren't you working on ICBM, or I don't know, a lot of stuff like that. Okay, so we want to do get values here. So we're gonna cheat on this, and we're gonna have to initialize some stuff. So we're gonna have to go sections. And we're going to do section 1 this time, equals new chunk short section. And then we're going to grab this again. And we're going to go data, and we're going to go like maybe value 1 equals 67. And what we want to have happen is essentially just the assert equals returning, well, exactly what we want it to return, which is 67. So this will be chunk.getValue, and we just stored it at pretty much that. So that should work, and we should get a full test back, and should be good to go. Oh, we got a broken system there. Oh, we need to. This needs to be 16. Still got a failure on that? This is why we're testing for, is that there is clearly something broken. Okay, so what we're going to do is we're going to run this debug, and I'm going to follow it through, and I'm going to watch out functions. Okay, so we get the y value. That should give us 1. It does. Add to active seats. Okay. I think that test stuff we just ran here like a few minutes ago just finished. Okay, so this is the part that probably just failed. Is that right there? That's what I want to say just failed. Yeah. See how it put Y16 in there? That shouldn't have been 16. So what did we miss here? Because when we're running the chunk data sections, no, we're passing in values here, so I mean I could put a percentile there, which is a modulus, is how it actually is called, but that is not exactly CPU friendly. We're just going to do it for the moment because something's clearly... It worked down here though. No, we didn't test Y values down here. So this is where I was talking about you can have 100% test coverage in your test and you can still end up breaking something. Is that you could have missed something really obvious, but then the system is like, hey, no, you're good. You've tested 100% of things. So we missed something. So we want to do this real quick. So we want to make sure we have a Y value there. And we're going to want to set this to 20. And you know, we had that previously at 11 and it was working just fine. The Y values are not quite right. I can't believe I wasn't paying attention to that. So we're passing in a level of 11 in here, yet this validated is true. You know, I'm going to get rid of these real quick. I'm going to call this. We're going to call get 10, 11, 20. because we're not exactly doing what we probably should have done in the first place, and is that we're trying to take the easy way out of doing this. Okay, so we go ahead and do 20 on this. We'll do that. We're going to launch this again, and it's probably going to fail on this set as well. Yeah, it's going to fail on this set. Now you notice how when I changed the get to use the modulus, it worked just fine. So there is something wrong with an and statement, which we are using an and statement in a couple other places, so I'm kind of curious why it's not functioning in other spots. Because you can see we use it in a lot of different places. So this is the extended block map, and it does the same thing. Well, we're using 15 here. Let's try that. I think what just happened is I just got mixed up. Yeah, we got 16 here. And that's the problem right there, is that it's going to do the AND operator, and 16 is going to validate as a pass-through. But if you did it with the 15, it would have turned it into 1 or 0. I think is what it's going to turn it into. Hit debug on that again. Test give value, test init work, test set didn't work. Shoot. Okay, so we're going to run a debug through again here, so I can watch what it's doing. So we come back through here. Of course, it's going to take us down to this. So we're in the 0 state. It creates us a section. We want to come in here, and it's still the y value is still at 11, which, you know what, that's actually perfectly fine. Our P is going to be 2,740. So that's 250. We're in the programming mode, aren't we? Go to standard real quick. So 256 times 10 plus 11 times. It's probably not going to work. Yeah, it is not going to work. Okay, so we'll try that again. So we're going to go 10 times 256. We want to memory store that. Then we want to do 11 times 16 plus 20 plus memory recall. So it's given us 2,040. This one says we're 2,056. Our Z is too high. That's the reason why it messed up. So what we want to come down here real quick and do is go, okay, actually, we just need to fix our JUnit test. I was going to fix that down there, but I realized if you add a couple if methods down here, you're going to slow that down a little bit. And it's best to just fix the problem to start with. Okay, so we can't use 20 here. This needs to be inside of 15, so we're going to put 15 here. Make sure we change it in every spot. Okay, let's run that again. I think that was the only thing was causing that one to fail up there, is that we were outside the bounds. Nope, still failing. Okay, so let's put our break line there again, and we're going to run it again. And what we at time-wise? 58 minutes. Almost towards the end of this. I'm going to cut this as soon as we get this fixed. Actually, we didn't fail there? We failed on ensuring that this line down here was correct. So that's 10, that 15, and it doesn't equal. So let's go into here. So it's doing 2751. Now let's go ahead and pull the calculator up real quick to confirm that is correct. So we have 10 times 256. I put in 20, didn't I? 10 times 256. Okay, so we want to memory save that. Then we want to do 16 times 11 plus 15 plus memory recall. So that is correct. That is the correct number. And of course, it's going to do the array there, which I'm surprised it does not. Doesn't tell us what we get back. Does it just say 0 is what we get back? Yeah, it fails right away. Does it? Oh, does it keep running? Yeah, surprised it kept running. Let me check to actually see where that failed at. It actually failed on this one right here. So okay, so this top one's okay. So these top two statements are fine. It's this one down here which is having difficulties. So this has to probably do with the y value not quite clearing through. And yeah, yeah, this line is gonna not work at all. So if you're between 0 and 15, then your next, you want to go up 5 more. This is actually probably 4. So let's try that. So we're going to run again, run debug. And we're going to, it fails on that first line. Okay. Why are you failing on the first line? You're failing on the first line because that's never going to be what that is. Okay. It's going to be 0. So let's go in here real quick. So that should end up with 1. And if we come into here, yep, we end up with 4. It sets correctly. Our previous value is 0. So call set value. Of course, that's like lazied out, so that looks good. Cool. So now it's just a get one that's having some problems. And we just showed that the get actually does already work in the this method here, because this one actually does use get in the process. So it's just something with how we've set up our test case here, which is failing. I want to say it's something here. So let's launch. So go in here. Okay, we should get a value of 1 there. We go in here. Yeah, we're getting a 1y off that. I don't think that's correct. It might be why we were using 16 percentile, which didn't make any sense why that. Because now we're getting y equals 1. And what was our height we set on the test? Set 16, this should be 0. So let's go look at get value here and make sure we're using 15 here. It'd be like 0, 1. Because when you get to 15, you're at 16. So that means 15 is your 16th value when it comes to y. And then when you get to 16, you're back at 0 again when it comes to this, how this thing's set up. That's why I don't like bit operators. They're faster when it comes to the CPU though, which is the reason I'm trying to use them, because they do run faster. Because you're just moving a bit around. A computer is amazing at moving bits around. It actually struggles when it has to do like division and stuff. Division, multiplication, it's actually computers struggle with stuff like that because they're not designed. I mean, they are designed to do that, but their on-off switches are not good at that. Now we're not going to notice the defect up here because this is using the set and get method in the same call. So these should always validate to the correct positioning. The weird thing is 20 turned into 4, which is what we exactly expected to do, because 16 would have been 0, 17 would have been 1, 18, 2, 19, 3, and then 24. But when you go look at this, 16 for some reason is turning into 1 when it should turn into 0. Let's take a look at this. So we're passing in y. we're doing percentile still here. That's what reason it's not working. Okay, so there, stop our test real quick and we run debug again. It's gonna hit my debug line, which I'm gonna remove here. And it should work. And it works perfectly. So what we're gonna do real quick, because I need to test this, is we're gonna do a full height test. So this is gonna be test y, and what we want to do is just make a for loop. So we go between 0, so int I equals 0, I is less than 256, I plus plus. So that should be full world height for us. And then we're going to go chunk.setValue, and we want to be 0, I 0, and we want to set the value to I. And then we want to assert equals I, and then chunk.getValue 0, I 0. So this is going to ensure that our full height check system works, which is the biggest flaw right now in our system, as you just saw, and it does work completely. Now we can check testing the full length and size and width and everything that you want to. Actually, we go ahead and do that. We're just gonna do, yeah, that'll work. So we'll do that. This is going to be our x. Our x is going to be less than 16 because we only have the 16 by 16 playing field to work with. Do 16 here, do that, and then we're going to change this to y. So for this, what we want our value to be is we're just going to go int, and we're going to just r equals math helper dot random, or yeah, we'll just do that, random short, and we'll put that there, because we don't really care what that value is as long as it matches up. And we're going to do the same thing here. This will give us 100% test on every single slot. So what this is going to be, actually what we're going to do is make a second method for this. So that's going to be our test y, and this is going to be our test all slots. And we're going to get rid of this on here, and we're going to get rid of this here. So this is going to be test that all y levels work, and this is going to be test that every slot works. And debug. And there we go. That's pretty much definitive proof that everything works. So I'm going to go ahead and end the video here, take a break, and I'll be back with the next video.